Okay, so in this on these four problems, you were to solve each square root equation. So these are radical equations. In particular, they're square roots. So the indices for each of these radicals is 2. So square root. Now, to solve a square root equation or to solve a radical equation, the procedure is to get the square root by itself. In this case, the square root by itself. So in the first two problems, the square root is by itself, okay? But in numbers 3 and 4, the square root is not by itself. So in 3 and 4, you're going to have to isolate the square root first. Okay, so when solving a square root equation, so let's go ahead and look at number 1. So I'm going to do number 1 here. So we have the square root of 12 minus 4x is equal to x. All right, so the idea is to first of all get rid of the square root. Get rid of the radical. So the way to get rid of a radical, whether it's square root, cube root, fourth root, is to raise both sides to a power that's equal to the index. So I'm going to square both sides. So in each of these, you're going to notice that at some point, I will square both sides. All right, so the square and the square root, they undo each other. So basically, remember, the square root of 5x times the square root of 5x is just 5x. Okay, so the same idea applies here. The square root of 12 minus 4x, that's 4x, times the square root of 12 minus 4x is just 12 minus 4x. So remember, you can write it as 12 minus 4x squared, and then you can write this as 12 minus 4x squared divided by 2. So so you can write a radical as rational exponent. So that's one of the lessons you had in the past. So 2 divided by 2, which is 1. So this right here is just this to the first power, which is just 12 minus 4x. So this is 12 minus 4x, and that's equal to x squared. So we have now, so we went from the square root equation to an equation that's quadratic. So we need to solve this quadratic equation. So let's just go ahead, since the x squared on this side has a positive coefficient, let's just bring every term to this side. And let's go ahead and put in descending order. So we have x squared plus 4x minus 12 equals 0. So when I bring all these terms to the other side and put in descending order, this is what I get. All right, now these right here are going to be factorable, so just go ahead and factor this. If you want to use the quadratic formula, you can, but they are factorable. So x, let's see, 6 and 2. 6 would have to be positive, 2 would have to be negative. All right, so that's what we get. Then we're going to use the zero factor property, so I'm going to set each of these equal to 0, and then we're going to solve for x. So x equals negative 6 here, x equals 2. All right, now the other thing you got to remember about this, once you get to that point, once you get to this, you have to remember that when you raise both sides to even power, you may introduce what's called extraneous solutions. Okay, extraneous solutions or extraneous roots. All right, so what that means is that you could introduce false solutions. Basically, these two solutions right here, they are solutions. They're solutions to this quadratic. But the question is, are they solutions to the original problem, to the radical? All right, so you got to check to make sure that if any of them are extraneous, you can't use them. So that would no longer be a solution to the original problem. And all you do to check is just go back, just like you've been doing in the past for all other types of equations, is just go back and you substitute these values into the original problem. So we have to check. So you must check. So let's check x equals negative 6. All right, so I'll go back to the original. So I have the square root of 12 minus 4x equal x. All right, so I get the square root of 12 minus 4 times a negative 6, and I want to see if that's going to equal a negative 6. So this becomes the square root of 12 plus 24, which becomes which becomes the square root of 36, which is 6. But the question is 6 equal to a negative 6? The answer is no. So this would not be a solution. This is considered an extraneous root. So it is a solution to this quadratic right here, but it's not a solution to the square root equation. All right, now let's check x equal 2. You can do the same thing. X equal 2. So you go back to the original. Here's the original. 12 minus square root of 12 minus 4x equal x. Wherever you see the variable x, you can substitute 2. So I get the square root of 12 minus 4 times 2 equal 2. And so I get the square root of 12 minus 8. This becomes the square root of 4, which is 2, and 2 does equal 2. So 2 is a solution. So the only solution in the blank, the only thing you would write would be x equal 2. That's the solution. Okay? All right, now again, some students seem to think that anytime you get a negative value here, you can't use it. That's not true. All right, so that's not true. It depends on what the original equation looks like. Okay, so you just go, to be on the safe side, just go and substitute. So sometimes it works, sometimes it doesn't work. Sometimes a positive solution works, sometimes a positive solution does not work when you get to this point, when you solve this quadratic equation. All right, so you must check for extraneous roots by going back to the original problem. Okay, number 2. So number 2, you have this equation, the square root of 5x plus 14 equal x. All right, so the square root is already by itself, so the next step is to raise both sides to a power equal to the index, and the index is 2, so that means I'm going to square both sides. So 5x plus 14 equal x. All right, so I'm squaring both sides. All right, and then the square and the square root undo each other, so basically you're left with 5x plus 14 equal x squared. So again, if you look at this is now quadratic. So I'm going to do it the same way I did the previous problem. I'm going to put this in standard form. So I'm going to bring it, since the x squared here has a positive coefficient, I'm going to bring these two terms to the other side. So I get x squared minus 5x minus 14 equals 0. And I put it in descending order. So I'm going to factor. All of these are going to be factorable. You don't need to use the quadratic formula. They're all going to be factorable. So xx, let's see, 7 and 2. 7 is going to be negative, 2 will be positive. And then we're going to set each factor equal to 0. I'm using the zero factor property. And then I'm going to solve for x. So I get x to be 7, x to be negative 2. All right, so again, these two are solution to the quadratic equation, to these two quadratic equations, but the question is, are they solutions to the square root equation? So whenever you raise both sides to an even power, you may introduce extraneous roots, so you need to check. So we're going to go ahead and check x equals 7. So look at the original problem. That's the original problem. Where you see the variable x, I'm going to substitute 7. So I get the square root of 5 times 7 plus 14. And we see that's going to equal 7. And x is 7. So 7 times 5 is 35. 35 plus 14 is 49. And so the square root of 49 is 7, and 7 does equal 7. So 7 is going to be a solution to the original problem. We just checked it. Let's check negative 2. So let's check to see if negative 2 is a solution. So I look at the original problem, which is this. And wherever you see the variable x, I substitute negative 2. So I get 5 times negative 2 plus 14. And I want to see if that's going to equal negative 2. All right. Well, right away, you know it's not going to work because this side is going to be positive, right? And this is negative. So positive is not equal negative. But let's just go further. So it'll be 5 times a negative 2 is negative 10. Negative 10 plus 14 is 4. And the square root of 4 is a positive 2. And a positive 2 does not equal a negative 2. So this does not work. That would be considered an extraneous solution and a false solution. So it's a solution to the quadratic, but it's not the original problem. So your answer is going to be this. So x equals 7. That's the only solution. Okay, number 3. You had the square root of 5x minus 1 plus 3 equal x. All right, now you don't square both sides just yet because you got to get the square root by itself. So I have to subtract 3 from both sides first. And so I get the square root of 5x minus 1 equal x minus 3. Now once you get the square root by itself, then you square both sides just like this. You put both sides in parentheses and you raise the both sides to the second power. The square and the square root undo each other, so you get 5x minus 1 on this side. On this side, now be careful, most students, not most, but there's a few students that will make a mistake and they'll say x squared plus 9. That is not x squared plus 9. Remember, you're squaring a binomial. Whenever you square a binomial, you're going to get a binomial. I'm sorry, you're going to get a trinomial, excuse me, a trinomial. So x times x is x squared. The outer's a negative 3x and the inner's a negative 3x. That's a negative 6x. And a negative 3 times a negative 3 is a positive 9. So you get a trinomial. So they become x squared minus 6x plus 9. All right, and then so now I'm solving this quadratic equation, but it's got to be in standard form first so I can factor and use the zero factor property. So I'm going to subtract 5x from both sides. When I do that, I get a negative 1 equal x squared minus 11x plus 9. I'm going to add 1 to both sides. And so I get 0 equal x squared minus 11x plus 10. And I'm going to just go ahead and transpose both sides. So I get x squared minus 11x plus 10 equals 0, just so I can get 0 on this side. It doesn't matter. All right, so let's factor this. So when we factor this, I get x minus 10, x minus 1. X minus 10, x minus 1 equals 0. And then I said each factor equal to 0. And so I solve each linear equation. So I get x to be 10, x to be 1. All right, so I got to check those because remember I raised both sides to even power. Whenever you do that, you could introduce extraneous roots. So let's check this. So let's check x equal 10. So you go back to the original problem where we see the variable x, you substitute 10. So I get the square root of 5 times 10 minus 1. So here's an example where you don't see any negatives. So both of these could work, both of these could not work, one of these may work. Plus 3 equal x, which is 10. So I want to see if that's going to equal. Well, 5 times 10 is 50. 50 minus 1 is 49. So we have the square root of 49 plus 3. Square root of 49 is 7. 7 plus 3 is indeed equal to 10. So x equal 10 is a solution. All right, let's check the next one. So we're going to check x equal 1. Check x equal 1. So I get the square root of, where we see the variable x, I substitute 1. So I get the square root of 5 times 1 minus 1 plus 3. And I want to see that's going to equal x on the side, which is 1. 5 times 1 is 4. 4 minus 1 5 times 1 is 5. 5 minus 1 is 4. So we have the square root of 4 plus 3. Well, the square root of 4 is 2. Is 2 plus 3 equal to 1? The answer is no, because remember, 2 plus 3 is 5. So 1 does not work. So 1 would be considered an extraneous solution. So the only solution then would be x equal 10. That's your only solution. Okay, and then finally number 4. So number 4 looks like this. We have the square root of 5x minus 9 minus x equal negative 1. All right, so remember, before you square both sides, you got to make sure you get the square root by itself. That's the first step you got to do. So I'm going to add x to both sides first, and then I get the square root of 5x minus 9 equal x minus 1. Okay. Now, once you get the square root by itself, then you're going to raise both sides. That's 5x minus 9 here. That's 5x minus 9. So then you're going to raise both sides to the second power. Okay, since the index is 2, that's if this was cube root, you'd cube both sides. If this was fourth root, you'd raise both sides to the fourth power, and so on. Then the square and the square root undo each other, and so you get 5x minus 9 equal, now be careful here, just like the previous problem, FOIL this, rewrite it like this, and then FOIL. You're going to get a trinomial. So this is x squared. The outer and the inner, you get negative 2x. A negative 1 times a negative 1 is a positive 1. So that's this right here. X squared minus 2x plus 1. All right, so now this is quadratic. to solve this quadratic equation, I need to put it in standard form first. So let's go ahead and subtract 5x from both sides. And so I get negative 9. When I combine like terms, I get negative 9 equal x squared minus 7x plus 1. Add 9 to both sides. I get 0 equal x squared minus 7x plus 10. I'm just checking to see if it looks like the very first previous problem. Okay. All right. Almost, except the middle term. All right, so we get x squared minus 7x plus 10 equals 0. I just transposed both sides. All right, so we're going to factor now. So let's see, x minus 5, x minus 2 will work. And we're going to say each one equal to 0. So x minus 5 equals 0, x minus 2 equals 0. So x is 5 and x is 2. All right. Now again, I got to check these because remember, these are solutions to the quadratic equation. But they may or may not be solutions to the original. Because remember, when you raise both sides to an even power, you may introduce extraneous roots. Okay, so false roots. So these are solutions to these, but it may or may not be a solution to the original. Always go back to the original. All right, so let's check x equal 5. Let's check x equal 5. All right, so here is the original. I'm going to just go ahead and rewrite it. Square root of 5x minus 9 minus x equal negative 1. All right, so where you see the variable x, I'm going to substitute 5. So I get the square root of 5 times 5 minus 9 minus 5, and I want to see if that's going to equal negative 1. Well, 5 times 5 is 25. 25 minus 9 is 16, so this is the square root of 16 minus 5. Well, the square root of 16 is 4, and 4 minus 5 is indeed equal to a negative 1. So 5 would be considered a solution to the square root equation, to the radical equation. Now let's check x equal 2. All right, so I'll go back again to the original equation, which was this, 5x square root of 5x minus 9 minus x equal negative 1. Where we see the variable 2, I substitute x. So I get the square root of 5 times 2 minus 9 minus 2. And I want to see if that's going to equal negative 1. Well, 5 times 2 is 10. And the square 10 minus 9 is 1. And so I get the square root of 1 minus 2. The square root of 1 is 1. 1 minus 2 is indeed equal to a negative 1. So in this case, both are solutions. So your solutions are x equal 5 and x equal 2. So those are your two solutions. So they both work in the original problem. Okay, so that's that should be enough practice for this type of square root equations.